Hold up on your phone.
I can't remember his name.
Oh, I have
He's
the-
more in the
Oh, yeah,
medical
you have that.
sciences. And I feel like he didn't get a whole lot of that. Cause we're pretty
Yes,
expensive. Yeah. So yeah, that one you don't have to take right away. Um.
Okay, I want to remind you two of you didn't upload your lab assignments from last week. Thomas, you didn't upload.
Yeah, I have it on my.
And you didn't do it till Friday, but get it in. If you have forgotten to upload any of those, take care of them now. I'm going through and checking all those off. You know, I don't grade them, but I look at them and then I just give you 100% if you did it. So, okay, today we're gonna finish locomotion. I've got a Mentimeter quiz for today. And then we'll start defensive adaptations. Tomorrow we'll do snakes of snakes of Idaho. And we've got, well, there's 12 species of snakes in Idaho. There's 11 for you to, learn. Let's see. We'll finish defensive adaptations on Wednesday and start amphibian reproduction. And we'll do amphibian reproduction, continue it on Friday. I looked at the weather report. It looks like the weather might be good enough for a field trip on Friday or on Saturday. We would go probably late morning to early afternoon or afternoon, depending. It's only gonna be, according to the weather, they estimate it'll only be around 64, which is just about, if it's much cooler than that, then your chances aren't real good. It's gonna be windy too, which really cuts down on herp activity. If it's real windy, they tend not to be as active, yeah.
Where would we be going for the field trip?
We'll go down between Ingham and McCammon. The university has two large properties down there. They've got almost 300 acres. One is called McCammon Pond. And we're likely to, if it's a good day, we'll see skinks and sagebrush lizards. And occasionally we see a gopher snake or a racer garter snake there. And then, and one time I was down there with a guy from Jackson Hole. He saw a wolverine there. He was leaving
Was
there.
it like around this time?
It was the spring. I think
that
it was
area.
in April or May.
If that.
Yeah, and I didn't see it, but he's a naturalist. I mean, that's his job. And he called it into Idaho Fish and Game, and they said, yeah, we heard about that. There's a wolverine that was telemetered that they've got locations of it up on Chinese Peak. They're migrating through, they're not staying. But grizzly bears have occasionally migrated through this area too.
Wow.
Yeah. And then the main thing would be going up to the O'Neill Ecological Preserve. That's 100 acres. That's a whole series of, when they put in the railroad, they cut off all the oxbows. And so there's up to there's 20 odd ponds that are along there in a wet year. Last year I was out there, it looked like there were 3 rivers out there. And we usually see leopard frogs, and we'll hear the chorus frogs, and hopefully we'll see some. It might be a little early for eggs and tadpoles. And if we were real lucky, we'd get to see a tiger salamander. And we're not a terrestrial garter snake is possible. One time in the last 30 years, I've seen a common garter snake out there. They're really rare. But if the weather turns bad, then we won't go we'll just kick that back a week, but
Okay.
anyway, I'm gonna ask you this in many meetings, but how many people, if the weather's good, how many people plan to go on that?
This Saturday or?
This Saturday? 1, 2, 3, 4. Okay, well, if it's only 4, we can go in my van and save a ton of money.
And, do you plan to handle the reptiles if you find them over there?
Oh, yeah.
Yeah.
Oh, yeah. Yeah, you gotta be real careful with the skinks though, because their tails come off real easy.
And that will be, between Income and McCall, right?
McCann,
Income, sorry.
yeah, we're not going to McCall. It'd be nice to go to McCall. We could look for Idaho giant salamanders and tail frogs up there.
Would they be around this time of year?
They're on the streams, so you probably could see them. Well, the problem is this time of year, the streams are really cold. They may still be icy, and usually it's not until later in the year that you can really do much in the streams. Like they don't do the fish surveys in the streams. Okay. Oh, let's see, I gotta set up Mentimeter here. I forgot to put it up, turn it on. Go ahead and enter your last name. Okay. Just so I know for sure, this will help me remember who is planning to go, assuming that the weather is good.
And that will be the 20th of this month?
Pardon?
Well, that field trip will be the 20th of April?
If it's this week.
No, this weekend.
So what?
What is that? It's the 8th, it'd be the 13th. The 20th, if you guys, the 20th or the 27th, I will be happy to do a trip. If the weather's okay, we could do a trip over to the Birds of Prey area too. But, that's a problem timing wise, because it's before you give your presentations on that following Tuesday, and my guess is you'll probably be wanting to work on that. And then on the 27th, that's before finals week. But if there is sufficient interest, I'll do the trip. I'd want to have 4 people to justify charging the department a couple $100 to go there to do that. Okay, so we got basically 4 people. Great. I've got a van and I can seat 4 people in there comfortably. And then See, if we buy, because it's off-road, we have to use a four-wheel drive vehicle from the motor pool, and they charge $125 a day plus something for mileage, so it's pretty expensive. Okay. What are 3 structural adaptations for burrowing? Remember, we talked about this? Give you guys a chance to. Some of the animals that we talked about were what, rubber boas? That was a real good example. We talked about spadefoots as burrowers, tortoises. Amphisbaenids. Okay, let's see what you're coming up with. Nope. Yeah, lack of limbs or large forelimbs. Don't think I'd call it an upturned nose, I'd call it a subterminal mouth, but the nose overlaps the mouth. The idea is to not get dirt in the mouth. Limbs, I guess some of them have limbs, but a lot of them don't. Wedge head shape, that's good. Reduced eyes, that's good. Smooth scales, that's good. Fused skull bones, that's good. For some of them, digging arms. Spade feet, yeah, excellent for the spade foot. Okay. Okay, I showed you, what did you think of that video of the geckos?
That was
Pretty cool.
Wasn't that neat?
Yeah.
That I shared an office with Bob when I was a postdoc. He was about the brightest guy in my cohort of graduate students and postdocs I ever saw. He's a distinguished professor at Berkeley. He's really, really a bright guy. When he was getting started, the Office of Naval Research came to his lab and said, "We'd like to fund you." And I think they were giving him, at that time, it was a couple $100,000 a year. And he said, "Okay, what am I supposed to do for this money?" And they said, "Just keep doing what you're doing." And they were using what he was doing for designing robots for warfare. Yeah, he was part of this team that was working on that. It's very, very interesting work. Although I must say that I guess if you're doing what you're doing, then you're not doing anything different. But the idea of your research being used for warfare is not particularly appealing to me. Yeah, that's the interesting thing. I hadn't heard, he said their estimate was billions of those little SETI, at the end of the SETI and then the little bristles and things, but apparently the surface area is so great that weak molecular forces, van der Waals forces, are sufficient to hold it in place. And I mean, that's not like a negative positive charge. It's an attraction between neutrons. I was trying to read up a little bit about it today. I don't know much about it, but I just think that's one of the coolest locomotor adaptations of any animal is the gecko. Okay. This last one is just to get you thinking about today's lecture on, defensive adaptations. And there's lots of different defensive adaptations. We've talked about a lot of these like toxins and things. But there are three major categories or types of defensive adaptations that you can fit almost everything into. Think about it. You can talk about it amongst yourselves if you like, but what are major types of defensive adaptations?
Actual defense adaptations. I mean. Defense can also be like. Yeah.
Or like just put armor.
Oh, armor's good.
Audible sound like a rattle.
Yeah. Rattle, the same.
I mean, snakes use it.
I'm gonna add biting.
Don't wanna mess with
Warning.
Okay, was this, will they use the same color?
Yes.
Like,
Okay, so the first major category, I see one answer here that, or two answers that fit into that and potentially two others. And the first major category is what we call crypsis. Basically, you hide and hopefully the predator never detects you. Okay, so that's category one. Or type one. Type two, which you would think, I would think is the most obvious one. And nobody has mentioned it. What's the most obvious thing that animals do to avoid predation that you guys haven't mentioned here?
Run away.
Run away. Yeah. So first, don't get seen, don't get detected. If you get detected, run away, escape. And then everything else here fits into the third category, which is called engagement. Okay, so you've got, if they try to bite you, they get a horn, or they get toxins, or at least they think, because of mimicry, you might be tricking them into thinking you're poisonous, right? You might bite them. Fangs, yeah, might make sounds at them, things like that. Okay. All right, well, that's it. I think though it's good to just pose these real basic questions to get you thinking about it, because it's so easy to just sit there and, listen to somebody mention the things, but if you think about it a little yourself, I think you're more likely to remember it. Oh, I forgot to, did I forget to load locomotion? Oh, there it is. Okay, I was so excited to get to the gecko feet that I jumped over some of this stuff last time. But snakes, snake, I don't know. I mean, I've read a lot and watched, observed a lot of snakes moving, but to me, it almost seems like magic, the way they move. I mean, you can break it down and understand it, but it's just remarkable to watch. So these are the major modes of snakes for crawling. There's lateral undulation, which is similar to what we were talking about in swimming, right? But it actually involves different muscles, and it's energetically different too. And then there's rectilinear locomotion, there's concertina, and there's sidewinding. These are the four main modes. People often come up, or sometimes come up with different modes, but these are the main ones. Um. Let's see. These are pictures of, these are videos. We're running a little behind, so I'm not going to show these, but you'll get a much better feel for snake locomotion if you look at these videos, right? Oh, but you guys can't look at these with the PDFs, can you? I better put the PowerPoint up there for you. So here's lateral undulation. Oh, the PowerPoint will have the notes too. So I'll change that and get that up there for you. Um. So lateral undulation, it's also called serpentine movement or curvilinear movement. And it's basically to move in waves. And like we talked about with swimming, that lateral undulation is produced by sequentially contracting and relaxing muscles along the length of the body. This is the most common mode of snake locomotion. And snakes also use this when they're swimming. When traversing solid surfaces with irregularities, or when traversing unevenly spaced solid surfaces such as branches. And this is also used by salamanders, legless lizards, amphisbaenids, and apodans. Now, an interesting thing here, then this will be different from some other modes of locomotion we look at. There are no points of what we call static contact, okay? But when these snakes are moving through here, these points of contact, the body's moving across those points of contact, okay? When we look at concertina locomotion, for example, you'll see, and I think rectilinear too, you will see points of static contact. Oh, and sidewinding too. And here's just a little bit about performance. I looked up some, this is from Halliday and Adler's Encyclopedia of Herpetology. Rattlesnakes have been clocked up to 2 miles per hour. Racers at twice that speed, 4 miles per hour. African black mambas have been measured going around 7 miles per hour, which is fairly fast. That seems faster than it is, though. When you watch them, it looks like they're really going fast. When we get to defense, we'll talk about some optical illusions too that the snake patterns can create when they're moving. Apparently, there are differences from swimming. The number of segments in block smaller for terrestrial locomotion, so it's not the same pattern of muscular blocks being activated. Different muscular mechanisms and patterns of force generation. And what we found in our research was that it had different thermal optima. That was very interesting, that the thermal optima for crawling or swimming was lower than that for crawling, which was interesting. It's not physiologically, it's not swimming on land. Okay, here's rectilinear locomotion. And I think this probably shows it pretty well, that you have these muscles, you know, like going from the skeletal system, like from the ribs, and attaching to the dermis here. And as they contract, then, now these are, as they contract, then that'll pull the animals forward. But these are points of static contact. I mean, of non-static contact. Excuse me, there's static contact. I gotta get that right. So alternate sections of the ventral surface are lifted off the ground and pulled forward by muscles originating on the ribs and inserting on the ventral scales. Does not involve lateral bending, so you can see snakes, like if you watch, where I've seen this most clearly is in pythons. When you have we used to feed our reticulated pythons, chickens and pigeons. And the snakes would crawl up to them and they'd get to maybe within 5 feet. And then they very slowly, through rectilinear locomotion, they'd crawl up straight and then they'd stop. And then over a period of like 5-10 minutes, through rectilinear locomotion, they gather a coil. So the head hasn't moved at all, but now they have an there, and then they can strike and grab the thing. So it's, but you can watch rubber boas or ball pythons, things like that. And if you watch closely, you can actually see the scales moving. Taking chunk, just like it shows them in this diagram. Okay, if this is slow, straight line movement, effective even when the surface is relatively smooth, and it's most often used by heavy-bodied snakes like boas and some of the big viperids, like gaboon vipers. Those show this kind of thing. May also be used to supplement lateral undulation to improve grip on the ground. Racers will do that. And often used to stalk prey. Okay. This is what's called concertina locomotion. The animal coils up, like let's say it's going up a tree, okay? It can coil or could be like moving in a burrow or a tube. It coils, it anchors anteriorly and then pulls forward to move a new coil. Anchors posteriorly, pushes forward. Okay, so it's anchoring at different places and moving forward, but it does involve static contact. Used in narrow places such as rodent burrows, for example, against the walls of the burrow. Similar motions in some climbing snakes. Used by amphisbaenids underground. 2 ways can go both forwards and backwards using this technique. So this would be comparable to moving in a burrow, and this would be crawling on a limb. Okay. And then the last one is sidewinding. This one is kind of hard to, I think other people may understand it better than me, but here's the description. So this is going to involve static contact as well. The loops are swung forward, then placed on the ground with force exerted downward, powered by continuous and alternating waves of lateral bending from the head back. So they're literally throwing a coil out, connecting it, and then throwing another coil out and throwing it out like that. And so that leaves a trail that you can actually see in the sand. I had a friend that was studying sidewinders down in the Mojave Desert. And he had, when we do our radio telemetry on the rattlesnakes here, like once a day, we find out where they are. And so, and all we can do is draw a straight line between those 2 relocation points. But he would actually know how his snakes got from one place to another because he could see their tracks in the sand. Okay, energetically, this is interesting. I guess this is also why you need to do experiments, because the way you think things should be are not always the way they should be. When I was an undergraduate student, the little research that had been done on this indicated that snakes were more efficient at locomotion than tetrapods, than actual, walking animals, because they weren't moving their center of gravity up and down. And when you walk, that's one of the things that's taking the energy, is you're moving your center of gravity. But the actual studies that have been done since that time, that the cost of lateral undulation in snakes is similar to the cost of walking in lizards. Concertina is actually more expensive energetically than lateral undulation, which is more expensive than sidewinding. No one has done the cost of rectilinear locomotion. This is surprising to me. Sidewinding looks to me like it would be by far the most energetically expensive. It'd be like you'd think it'd be like broad jumping all the time or something. But the studies have indicated that it's the least expensive. How do you think you do that? Oh, did you have a question?
Yeah, I was gonna ask, is it possible that sidewinding is less energetic? For the same reason that the snakes do sidewinding, so usually it's in like a desert, like sand area. So they're trying to get as little contact with the hot ground as possible. So it could be like that could play into why it's less energetic or less cost too.
It's definitely less energetic, and it's not clear to me why. I think this was a big surprise. They published this in Science and it got a lot of attention. Yeah,
I guess would be like, since they're not spending as much time on the ground, that lack of friction and the ability to just glide over small distances.
yeah, that makes some sense, yeah.
Plus, if they're keeping momentum up, that's helping as well.
Yeah, the reduction of friction, that makes some sense, yeah. How do you think they study this? How do you think we know this? Those of you that have had physiology might be able to answer this. How do we measure the cost of locomotion like in humans? Or in dogs?
Is it weight loss?
No?
Or oxygen intake?
Oxygen, oxygen, oxygen consumption, or carbon dioxide generation, either one. So how do we measure, if you want to measure your oxygen consumption, how do you do that?
Don't they usually have like a respirator or like a?
Yeah, you could put a mask on and you can use what they call, I think they call it flow respirometry, where they actually measure the concentration of the gases entering and leaving. And then they can calculate the oxygen consumption. You can imagine how difficult that is to do with a snake. They literally had to put masks on these snakes and then get them. I'm not sure about concertina. I can't even remember how they did that. Lateral undulation and sidewinding, they did that on a treadmill. And they had to work, and I think it took a long time to train those animals to locomote on a treadmill. The cost of rectilinear locomotion hasn't been, no one's done that yet. I would think that'd actually be easier, but because you wouldn't have to even move anything, you just put the thing on them and let them go.
But how do you force it to go, how do you force it to move linearly?
I think I do it in something like a rubber boa and just get it. I mean, if you put it on a surface there, most of the time or a lot of the time, they'll just move rectilinear. One of the students, quite a few years ago, was really interested in this, and I got a hold of a ball python for her, and we tried to use it, well, we didn't have the respirometry stuff. I mean, it was gonna be too hard for her to do that, but she was just doing observational things and making videos. And what she found was when she put them on a real smooth surface, they sideline. It's really hard to think of. I mean, I'd never heard of a python sidewinding, but it did. Okay, the next major thing is climbing, and we've already talked about that with respect to geckos. But the advantages of climbing are that they can often get to appropriate microhabitats. Sometimes you find, like thermally, the best place for animals sometimes is in trees, or in bushes. There's prey available there that may not be available elsewhere, like say frogs, tree frogs, for example. It's, it could be helpful for avoiding predators. A lot of animals are more arboreal as young. And then when they get older and bigger, you don't see them in the trees as much. Easier movement in some cases. I remember when I was down in Panama, we would see like 100 feet up in the trees, the iguanas, the big green iguanas, just jumping from branch to branch. They could really get around well. And for those animals that parachute or glide, those are where they're going to take off from. So here's some examples of adaptations. So here's a hyelid frog of some kind. It looks like a red-legged, red-eyed tree frog. Remember they have the toe pads. And apparently those are important not only in holding, well, they're important in holding on and like taking off or holding in place, but also when they're leaping, when they land, the toe pads help them stop. Some of these animals have adhesive type materials. They have remember that intercalary cartilage? That's that extra skeletal element right there, and that allows more precise placement of the digit. And they may have a wet ventral surface. You'll see this sometimes with frogs in zoos and things. You'll see them just plastered up against the front of an aquarium, just sticking there, but they can do that to leaves and probably some trees too. Okay, so here's an example. This is a arboreal plethodonid. It's in that big genus Bolodoglossa. And notice that it has these webbed feet that increase the surface area for climbing and adhesion. Here's a chameleon. Chameleons have, look at that picture and tell me what you see that you think is related to climbing.
Zygodactyl feet.
Yeah, the zygodactyly with the feet that, or with the digits that they're opposed, so it's kind of like clamping, yeah.
They also have that curled tail, which I think is prehensile.
Yeah, this is a prehensile tail. You'll see them actually hanging by that tail. And then notice how the posture of the limbs here, it's not this, it's more of a vertical orientation. Okay. Well, we already did this, so, oh, now here we are with iguanas. There's two things that you can see there. Well, I guess you don't see it really great, but there are two things about these guys that are two or three things that are kind of arboreal adaptations. Yeah.
Maybe long fingers.
Yeah, the long toes. And you'll see that, remember in the, I don't know if you remember when you're looking at the Scoloporus lizards, there's these incredibly long toes that allow them to grab onto things. So these guys, and they have claws, okay? They generally have a fairly elongated body shape, and then they have a real long tail. that they can use for balance. Do you remember the interesting character that these share with geckos?
They have the seats, they have some.
They have the CT2, yeah, or SETI. They have those as well. So these guys are pretty good climbers. They're not like geckos, but they're relatively good climbers. Okay, then snakes can climb really well. They have these real elongate bodies and they can use coils. And then the other thing about snakes that's really important, and I've mentioned this before, but the vertebrae interlock. They have these interlocking, and so they can hold their bodies out really, I mean, it's really quite amazing what they can do. Like 80% of their body they can hold out. And that snake did that. And if it didn't have interlocking vertebrae, it couldn't do that.
I've seen a video of a python lift a quarter of its body up.
Oh, yeah, that would be the concertina type locomotion. Yeah, let's see, I don't know if this will work or not.
I
Let's
have
try
a
it.
question.
Yeah,
So based on that picture, the first one, does the snake has to go further to a certain length to get up to that height? Yeah, like. In the first picture, the snake is, oh.
this one?
Yeah, that first one. The snake is moving forward. So does it need to go to a certain length to get up to that height in the second picture?
Gee, that's a good question. But I think I've got a video of a climbing snake. Let's see if that video answers that. This is from Australia. As I recall, well, let's look at this for just a little bit. Can you see that okay? This is not a very well edited video. I think you might be onto something there, though. It seems to me it'd be easier for them to do like that and then lift themselves than to go straight up. Maybe we need to do a video study of that tree snake from down at the Living Planet Aquarium to answer that question. That's a good question. I don't know the answer, but that seems not unlikely. Oh, this is really cool here. This is a corn snake that now it's called Pantherophis cutata, but you see how it's, the bark of trees often has, fair amount of depth to it. And snakes can crawl up there. In fact, these corn snakes, these rat snakes, have been known to crawl up the surface of rough cut boards. I mean, it's hard to believe they can do that, but they can. I've seen gopher snakes, like in the Frank Church, going up ponderosa pine trees like this. Because ponderosa pines have, pretty thick bark. Okay, and then I think this is the last one. This is parachuting and gliding. So what parachuters, the definition for parachuters is the line from takeoff to landing is greater than 45 degrees. So it's kind of a controlled fall. Well, they're both controlled falls, and then parachuting, and then gliding, that angle is lower.
That's following with style.
What's that?
That's following with style.
Yeah. Okay, so here's some examples. Here's a geckonid, and look at this, isn't this cool? See how they've got the webbing? And I don't know if you can see that here, but that's actually a flap, so that when they're jumping, those things fold out
Wow.
like a parachute. And even on the tail, see that? They've got these expansions on the tail. But here you can see it a little bit better. So this is the parachute gecko. And then Rhacophoros, remember the Rhacophoridea, and you see here, there you can see the flaps on the legs. Here on the sides, and I believe they have some other flaps too. But, oh, here's a flying snake. Oops. Well, that one's no longer there. And then this is Draco volans.
That's my favorite.
So these are, look how the ribs are extended. These are not very big lizards. They're really, the least ones I've seen have been quite small. But, let's just see if we can find a, let me see if I can find a. A flying snake video here. It used to be you didn't have to sit through these ads, but they. Watch lateral undulation there. No static ones. They're still moving, aren't they? Isn't.
That's incredible. Imagine having that in Taiwan. That's like so.
Isn't that great?
I'd love to see.
No, that was lucky to get that one.
Draco has evolved specifically to counteract the flying paradise. Like that predator prey dynamic was one of them. Like they both kind of, I would bet money they both evolved that, I mean.
Yeah, that may be.
Oh, like in a-
Well, we'll do defense on Wednesday. We didn't get to it today.
It might work out.
And they sort of.
Okay, so let me, copy the link or the coordinates you sent me
I mean.
and,
Yeah, see if that works.
Nah.